video, picking up on number 9. Twice the sum of a number and 4 is 28. Find the number. So it's twice the sum. So we have to do the sum first, which is n plus 4. And then we have to do twice it. So that's 2 times n plus 4 in a package. Distribute the 2. 2n plus 8 is 28. Subtracting the 8, 2n is 20. Dividing by 2, n works out to be 10. Letter B, 3 times a number decreased by 11. Decreased means to subtract. This time there's no twice the sum, so it's just 3 times a number decreased. So here's my 3 times a number. Here's my decrease. By 11 is 16. That's pretty straightforward. Standard two-stepper, add 11 to both sides. 3n is 27. Dividing by 3, n is 9. Okay, so when we talk about finding consecutive integers, for consecutive integers are always n plus 1, n plus 2, n plus 3, and so on. So there they are. And I always like to rewrite this in little mathematical symbols before I start filling it in. The sum of the first two, that's what it says here, the sum of the first two, plus twice the third, plus 3 times the fourth, there's 3 times the fourth, is 70. So here's my first one and second one added, that's the sum of the first two. Twice the third, right? The third one is n plus 2, there's twice the third. 3 times the fourth one's n plus 3, there's 3 times the fourth, is 70. So n plus 1, distribute here, 2n plus 4, distribute here, 3n plus 9. It's the same side, same operation situation. Altogether, I have 1n, 2n, 2 more n make 4n, 3 more n's make 7n's. 1 and 4 is 5, and 9 is 14. Equals 70, minus the 14 from both sides, 7n is 56, dividing by 7, n is 8, so I get 8, 9, 10, and 11 are those 4 consecutive integers. Number 11, find 3 consecutive odd integers. Such that, well, first off, 3 consecutive odd would be n plus 2, n plus 4. I know it might seem strange why consecutive odd are n plus 2, and n plus 4, but if you think about it, let's just say the answer works out to be 11, 13, and 15. To go from 11 to 13, you have to go up 2. To go to 15, you have to go up another 2, which is a total of 4. So this guy says 3 times the first, there it is, 3 times the first, increased add 4 times the third, there it is, 4 times the third, is 29 more than 4 times the second. So 3 times the first is 3n. 4 times the third is 4 times n plus 4, because there's my third one right there, is 4 times the second one, increased by, or 29 more than that. More than, switch the order, last shall be first, first shall be last. Little algebra here. Distribute the 4, 3n plus 4n plus 16. Distribute the 4 on the other side, 4n plus 8 plus 29. Little same side, same operation here. Group things together. That would give me 7n plus 16 is 4n plus 37. Subtract 4n from both sides. 3n is equal to, and then 37. I also minus the 16 at the same time. So I did it all in one step. Minusing the 16 is 21. Dividing by 3, n is 7. So those 3 consecutive odds are 7, 9, and 11. Now we'll go up to number 12. Find 3 consecutive evens. And just like the odds, they are n plus 2, n plus 4, such that 2 times the first, there it is, 2 times the first, plus the second, plus 3 times the third, there's 3 times the third, is 182. Find the largest even integer. And that's different, right? It didn't say find 3 or 4, it said find the largest even. So I'm only responsible for that biggest even integer. So 2 times the first is 2n. The second is n plus 2. And 3 times the third is 3 times n plus 4. And that all adds up to 182. So 2n plus n plus 2 plus, now distribute the 3, that's 3n plus 12 is 182. So that's 6n plus 14 is 182. Minus the 14, I get 168, divide by 6, and I get 28. So the third one, the largest one, is 28 plus 4, which is 32. Okay, number 13, the area of a rectangle can be represented by 10x plus 20. Which choice can represent the sides? Well, remember, area is length times width, so we're looking for 2 numbers that together multiply out to be 10x plus 20. And that choice, the correct choice is C. Distribute back. 10 times x is 10x, 10 times 2 is 20. Number 14, factor using the GCF. Well, what they share in common numerically is a 6, and in terms of variables, it's an x. So if I factor out what they share in common, they share a 6 and an x. That leaves me with 6x times 2x minus 5. And what we always say with these any type of factoring, is distribute back to check yourself. 6 times 2 is 12. X times x is x squared, so that looks good. 6 times negative 5 is negative 30, and then the x. So that works correctly. Number 15, factor each trinomial. Okay, I'm going to say this once at the beginning. You can use the AM technique, two numbers that multiply out to 40, add up to negative 14, or you can go to your calculator. You can put in under y1, 40 divided by x, whatever the last number is divided by x. And then under y2, I put whatever it is you put in y1 in parentheses, and then plus x. And then you look in the last column for where you see negative 14. And if you do that, the two previous columns will be negative 10 and negative 4, and that gives you the factors of x minus 10 and x minus 4. Not so coincidentally, negative 10 times negative 4 is 40. That's the multiply in the AM. And then negative 10 plus negative 4 is negative 14. That's the A as in add. So x minus 10 times x minus 4 is the answer. Next one, two numbers that multiply out to negative 18 add up to 7. That'll be x plus 9 times x minus 2. Now, letter C, we can throw all of the AM and the calculator out the window because of the 3 in front of the x squared. So now we have to go to what I call plan A, which is where you look for greatest common factor. And in this case, I find my greatest common factor, which is 3. So I get 3 times x squared plus 3x minus 4. And then I try to factor the resulting polynomial, or remaining polynomial, which I can do. It's x plus 4 times x minus 1, because 4 times negative 1 multiplies out to negative 4, and 4 plus negative 1 adds up to 3. The one thing you have to be very careful of here is in the answer, all 3 factors have to be included. The 3, the x plus 4, and the x minus 1. You cannot just put the x plus 4 times x minus 1. All 3 pieces, including the 3, must be included. Now, letter C we called plan A because we looked for a greatest common factor and found it. In letter D, we look for a greatest common factor and we don't find it. So that means we're going to go to plan B, our second option. And when we do that, we take whatever the lead coefficient is and we multiply it by the last term. And that gives me 10. 5 times 2 is 10. And I just rewrite the rest of it. So it's x squared plus 11x plus 10. So remember, we multiplied by the last term, okay? Then I factor what remains. And that works out to be x plus 10 times x plus 1. But if we're going to multiply and change the problem by multiplying by 2 here at the end, I got to come back in and divide by 2. So 10 divided by 2 is 5. And when I cannot simplify it, like I did in the first one, then I'm going to take that 2 and put it in front of the x, like elementary school dealing with fractions. So I get 2x plus 1. So it's x plus 5 times 2x plus 1. And this last one, we didn't do a lot of work with this, but it's as if there's 0x in the middle. So you're looking for two numbers that multiply out to negative 25 and add up to 0x's. And that would be positive 5 and negative 5. So the factors are x plus 5, x minus 5. Okay, number 16 says, what factor do the following trinomials have in common? So there's two different trinomials here, and we want to find what factor they have in common. So what you got to do is factor them both. The first one is x minus 7 times x plus 4. The second one is x plus 5 times x plus 4. What do they share in common? They share in common an x plus 4. Number 17, on their final, a couple of times we changed questions that tended to be a little more predictable algebraic, and we turned them into real-life application algebraics, and here's one of them. The length of a rectangle can be represented by 2c plus 7 and the width by 2c minus 11. Write an expression in standard polynomial form for the area. So I just have to do length times width, which is 2c plus 7 times 2c minus 11. Double distribute. 2c times 2c is 4c squared. 2c times negative 11 is negative 22c. 7 times 2c is 14c. 7 times negative 11 is negative 77. That gives me 4c squared minus 8c minus 77. Okay, number 18. Excuse my yawn. It's Thanksgiving evening here at about 10:46 p.m., so I'm getting tired. just fill in the values here for A, B, and C, which means you basically substitute in a -3 for x, a 0 for x, and a 3 for x. You just do it on a calculator. Just put in alpha y equals and then 2/3, and then multiply that by the -3 for A here, and then -7 will tell you -9. Or you could just do 2 times -3 divided by 3, and then -7. It'll also tell you -9. Both ways work. Do the same for 0 and 3, and A works out to be -9, B works out to be -7, and C works out to be -5. Okay, next up, number 19. Write the equation of a line in slope-intercept form that passes through the point -1, 7, and 2, 13. So, slope-intercept form is y equals mx plus b, which means I need a slope first, and to do that, I do the y from the second point minus the y from the first over the x from the second minus the x from the first. And if I do that, I get 13 minus 7. Doesn't matter the order. It works out the same either way. Over 2 minus -1. That's 6 over 3 equals 2. Don't forget the y's have to go on top. Y equals 2x plus b. Use either point. I use the second one. 13 equals 2 times 2 plus b. 2 times 2 is 4, so b works out to be 9. And the correct equation is y equals 2x plus 9. Only got a moment left here. Write the equation of a line with a slope of -4 passing through -3, 8. Y equals mx plus b, -4x plus b, because we know the slope's -4. Substitute in the point 8, -3. -4 times -3 is 12. Subtracting 12 from both sides, I get that b is -4. Combine that with a slope of -4, and I get y equals -4x minus 4. Okay, that's through question 20. Video 2 done.